Yeah, so let's have our next session, post-T, and we have Noy Rotbart, Tools for Technology-Assisted Education, please.
Thank you. So my name is Noy Rotbart. I'm a third-year PhD student for computer science at the Department of Computer Science at the University of Copenhagen. And first of all, thank you for inviting me again. I was on the first conference, and it was much fun, so should hope that this one has a good start. So it actually started better than the first one. So, okay. So I'm going to talk about tools for technology-assisted education. And I really love quotes, and this one I found particularly appealing. If you go back 120 years in time, everything would be different but the classrooms. This is a painfully accurate description of the author of Freakonomics, Stephen Dubner. And a really good question you can ask, if the remote would be so nice to go through it, would be, are we really harnessing the abilities of technology to the fullest? I mean, is it correct? I mean, could we have done better with technological tools? So, first of all, I'd like to ask you, the audience, I mean, do you guys have a good example of things you're doing, maybe Matt or maybe some other teacher here, something that when you're using technology that did not exist 20 years ago or 10 years ago and is present and helps you significantly to improve your education level significantly? Well, I would argue that three-dimensional figures worked very well before technology.
That was a difficult thing to do. Visualization.
Right. What's the name of the tool you're using?
Geometric sketchpad, all these things are there now.
So
it's not there earlier.
I'm talking, give me one tool that you're using. I'm an Israeli, I'm a hands-on guy. We like to, somebody say, look, take this tool works. Which tool are you using?
iPad. Which one? Calculator.
Calculator, thank you. Calculator, I guess, existed 120 years ago. And not even the blackboards, but they've been existing for more than that.
The ball pen did exist. Okay. The ball pen.
The what? The ball pen. Yeah. So the why not, I'm sure I mean, let's be honest, it's very obvious that we're not using technology to its full extent. I mean, right now this lecture is being recorded. You know, you could have, it seems plausible that there should have been some sort of an automation, mechanization of the process of education. It's a bit more delicate than that. We all know that intuitively. Okay? So the why not here, there are a million reasons. I guess a lot of them are partially right. I cannot think of a single good reason that is an absolute, you know, this is why this does not work. And you know, when we don't know the reason, how can we find a solution? So as far as I'm concerned, the problem is we're not harnessing technology, and I don't really know what the problem is. So I don't really know what the solution is, but I have some set of tricks and tips that would maybe help do something about that. So let's talk about the current notable directions. And the first one, and I find most compelling and least successful somehow, is MOOCs, massive online open courses. These are initiatives by people way smarter than me and way smarter than a lot of people I know to create, say, one course for Algebra 1 course for analysis that would be so extremely good and so well played that any student would be able to follow. And they have been successful to an extent. And that extent, we'll talk about later, but the idea of unification of education so that professors at 190 countries don't have to go and do the same thing again and again and just waste everybody's time. Okay. But we'll get to that. The second effort that I think is interesting is Khan Academy, which does something that I think is more compelling to tackle this problem. And what they do is, or what this guy started doing is, well, his cousin was having some problem with her math, and he was recording like a small 5-minute section for her about things. And that turned out to be ultra successful, and is now, as far as I'm concerned, the most interesting implementation of mathematical education or any kind of education that is being done online. And the third thing, which I find compelling from a different point of view, is a project called Duolingo, where they use cross-references from students to come up with good ideas, or good ways of teaching. Wow, this is interesting. Now let's do, fine, why not? To teach people languages. So this is more like a reference for you to look it up, because it's a bit off topic for me right now. So I would like to get a little bit into the Coursera experiment. Oh yeah. Yeah, I would like to talk a little bit about the Coursera experiment. The Coursera experiment, which is a for-profit company that tries to make education online massive available. They have a pretty sad number, and the number is that once a student signs up for a course, an online course, there's a 5% chance that he's going to complete it. So 1 of 20, that's a really, really bad number. Maybe the little less bad number would be that 40% of them cherry pick. 40% of them go into the system and tune in the right about week where the relevant material for them comes up. Somehow that is not very surprising. I think there's also a lesson to be learned here about how and in which extent can we use this online learning. And I think in that way, by the way, Khan Academy excels with respect to MOOCs. And then there's another interesting statistics that appeared in a movie about the decline of higher education, 2014. And they tried to take an elementary course in, I think it was Introduction to Programming, in the University of San Jose, which is, I guess, maybe a third-tier university. And they put 2 groups, and they gave one the regular curriculum, and they gave one the Coursera curriculum with some additive meetups. And there was a 30% difference between the people who passed regular method and the people who passed Coursera. To the bad, Coursera was performing significantly worse. And I think, off the top of my head, the obvious thing that Coursera or all of those MOOCs do not offer is the real sense of community. This is my, this is the obvious thing that happens to me when I'm trying to learn something online. Okay. So this sense of community is something we're going to discuss in the next 20 minutes or so. So another thing that I think is kind of interesting, or probably a huge problem for the effort of creating an online education. Well, I really love this citation. The Israeli newspapers use it all the time. All happy families are all alike. Every unhappy family is unhappy in its own way. You can feel it extremely well when you're teaching a student. Because, when you know it, you know it. When you don't know it, now starts the quest of figuring out what is it exactly you didn't get, and how do we get around it. And this is very hard to replicate in an environment that is totally digital from top to bottom. Okay, so my 2 cents on the entire on this entire field would be that it doesn't strike me as if in 2030 we're going to abandon classes altogether. Not in higher education or in basic education. It just doesn't strike a bell to me, but of course these are just my 2 cents. One thing that is definitely obvious about this is that instead of trying to solve the entire problem top to bottom, we want to be focusing on the details. So we want to be able to master technology-assisted education first, not technological education. Just got to do better as teachers, implementing ideas that uses technology. And one thing, one of the successes that everybody who tries to play guitar or fixes a bicycle will tell you is that YouTube is extremely useful at solving small tactical problems. YouTube, forums, whatnot. When you have a problem that is very well defined, whose solution could be replicated, could have been replicated, most likely, if you are of my generation, probably a little lower than my generation, well, you're going to go online and you're going to find a solution. You're going to Google it. You're going to YouTube it. So these things work extremely well, and the question is how to extend that, how to look at problems that are a concatenation of these, or the union of these problems. I don't have answers to these questions, but I think that it's pretty compelling to try and get bottom-up to the idea of how to study something that is a bit more complex than fixing your bicycle. Another thing that I would like to propose is that when we understand that the real strength that offline education has is the interaction, and that a teacher that that is here is just giving material, well, I would try to minimize the quantity of material that I'm putting in front of the class, and I would try to focus on creating a meeting point. So let me clarify by what I mean by a meeting point. By a meeting point, I mean, well, it could be a lecture, it could be a TA session, it could be a class it should be something that is seminal to whoever participates in the course. And by that I mean, right now, when we go to lectures, and I've been having discussions with this with Benny Shore here all through the week, I think, we go in and we get a bit opportunistic. Okay? We don't read up on the abstract, we don't read up on definitions. We come in and we expect to be fed. And now, well, the teacher has to be both YouTube and a meeting point and a mediator for our questions. And that we just simply don't have enough time for. We could eliminate the first one. We could eliminate the pushing the information that is trivial to read up on yourself. So if you were to divide the education circle to before, middle, and after lecture into a very, very concrete sort of contract that you make with your students, I believe that would be, first of all, very, very easy to figure out how to digitize. Right? Because if now the before part, well, this is the part that you should come to class with. Well, this can be automated. Okay, now you have questions on the something that happened before. The class is going to be devoted to that almost exclusively. We're going to tackle the hard stuff. And then the after, well, this is the part where exercises typically work pretty well, but you could also, of course, digitize exercises if done properly. We just found this citation, so I'm pretty happy about that. This was your president when?
8 years ago.
8 years ago. Okay, but he didn't. Who was the one who was assassinated? Nobody was assassinated. Our taxi driver yesterday was lying.
No, Rajiv Gandhi is the prime minister.
The prime. I'm sorry. I have zero knowledge about Indian. Right.
Indira Gandhi also.
I think I'm going to go to Khan Academy and figure it out. So far in our talk, we've been discussing current efforts in technological learning and zoomed in a bit about classes as meeting points. And what I'm going to do now is I'm going to give you an activity that I think could be easily digitized as a class activity, what you'd call the in-class activity. Okay? And the way I'm going to do it is I'm going to use a tool called Socrative. And this tool is an online tool that is performing, that creates very quickly quizzes and test notions quickly. Fantastic tool. Unfortunately for me, I forgot that I'm going to be in India with not so fast internet. So I could not operate this software here. And I realize now how big of a gap we still have to catch on, even for me. Here I am talking about implementing technology in education, and of course, one of the major problems is, what if the technology doesn't work? I still have a real-time thing with my students, right? So this does not work. Luckily, I didn't have to improvise because I was about to give you that as a lesson, or as a take-home point, which is in case Socrative doesn't function. So I prepared the class in an alternative method. So this is what we're going to do for the next 5 minutes, and this is a nice exercise. So try to do 2-on-2, and it starts with the following simple exercise. Suppose you go to a party, you meet 4 other people. Okay, maybe you know those people, maybe you don't know those people. Okay, so now my question for you, to show me that it's possible that no 3 people either know each other or don't know each other in this group of 5. So try to come up with an example where 2 of you know each other, every 2 of you know each other, and every 2 of you do not know each other. Okay, so try to take 3 minutes and talk about it. It is, and we're going to go on it, but please then explain it to somebody. No, this is, I'm dead serious. Take a pen and paper and start working on it.
You have 5 people and 5 people. So you have 10 edges. So.
What I think is, again, we have to organize
I introduce a get introduced.
Okay, so if this was a regular class and I had an hour, I would have started maybe by introducing a tool. And this tool, maybe I would have wanted you to do it beforehand, at home. But this tool just means that you ought to use some notions from graph theory or from graphs in general, where you're going to model this as the people are going to be nodes, and whether they know each other or don't know each other will just correlate to either it's going to be a red or a blue edge between them. And then I would like you, and then the mission would be to find a graph where there is no triangle of the same color. So this was the mission, and here's the proposed solution. Here's a graph that holds this property. Okay? So this would be getting into class, I guess, getting into the business. And now comes a follow-up. Suppose that now you're 6 and not 5. And now I ask you, well, what is the probability that this can happen, that this event happens? Okay, that 3 of you know each other or that 3 of you don't know each other. Okay? How much time do I have? I have some time.
You have another 5 minutes?
I have 5:52 here. Okay. Okay, so
We go by the time. That's it.
I have 5 minutes or 10 minutes?
You have 6 minutes.
6 minutes. Okay, so I have to speed up a bit.
Or if you're going to take the whole 30 minutes, then you have 10 minutes.
I have 10 minutes. I'm good. Okay. So here comes a part of a hint, which I always like giving hints. I think it's great to in a bit of a class. And in this hint, you say that if we're to look at one person, let's say we look at you now, and there will be at least 3 people that you know, and if there aren't 3 people that you know, that there are 3 people that you don't know. Okay, so if we were to make it into this graph, well, there are it either looks like this, where the number of red edges is at least 3, or the number of edges is at least, blue edges are at least 3. Okay, so I'll give you another tip. It probably doesn't happen, but I would like you to show me why it doesn't happen. Okay, so again, we don't have a heap loads of time, and I'm guessing that some people here know the question. So anybody knows the answer for this? Yes. The first one? Yeah. Okay.
So, if this is me,
Yes?
and those, I know them or I don't know them, but let's say they are in red,
Yes?
then, okay,
Let's do it with you, okay? So I guess this is your first step?
yes.
Okay.
No. There's either on top here,
Yes.
there's a triangle, other column.
Yes.
Or if one of those
Yes.
lines has the same color as this one,
Yeah.
So I'm going to say it in reverse order, which is that suppose that, okay, so now we had under the assumption that, and let's say without loss of generality, there were at least three red ones. Like at least three people that I don't know. If two of them don't know each other, then here it is. Here's three people that don't know each other. So this must not happen. Okay, if this must not happen, this means that those two have to be blue. Well, in this case, here is your three people that don't know each other. That knows each other, sorry. Well, they should also be, yeah. So you get, so well, to sum it up, either you had three people that don't know each other or three people that know each other, and that had to have happened. So this is a kind of a funny piece of math to know, which in a group of 6 people, there will always be 3 people that either 3 people don't know each other or 3 people know each other. Okay. So if we were to go further in this, then this extends to something called Ramsey numbers, and this is a very interesting and has a lot of open questions in combinatorics, but it has this core which says that for every such number, if we take, let's say 15, okay, there will be a graph, there will be a number such that all graphs that have this number of nodes, this number of people, if there are more than this number of people, then there will be 15 that either know each other or don't know each other. For every number you're going to give me, you give me a number, and I will give you the number of people where it must where it must always happen. It's a really beautiful thing to look at. So what I did in this example. So the first thing is that unlike regular class, and I'm sorry that you didn't get to see technology here, but even without technology, unlike regular classes, there has to be a little bit more I feel like there has to be a little bit more feedback. That feedback is very easily attained by technology, a little less easily attained by me talking to you, trying to do it more one by one. The second thing that I think is interesting, it could be very easily attained by technology, is that you try it out yourself. Now, when I sat down here and the lovely speaker before me spoke for the first 30 minutes, I was getting numb until she tackled me with something. She told me, okay, now you try to do these symmetries. Now you tell me what are the differences. And then I woke up. Because studying, strangely, is an active process. Okay? I know very few people who sit down and soak things. It always has to have been that you tried on yourself, and you failed, and then you pulled it off. And this is very easily done with technology. So there's a lot of incentive here to try and make that point. Another thing that I think is very nice in technology is the possibility of linking. So when we were done, I was telling you, look, this goes to Ramsey theory. Okay. So now I just said a name, but you have in your mind when you found it interesting, you already have a link here. Okay. And that link, well, this is an actual link. So when I upload it to whatever system we're going to use, you just go to that link, okay? Or you find your own link. But you have the point of reference, and that's very important. Something that we could not have done 30 years ago. Okay, you could have gone for an encyclopedia, but maybe it's a 5-year material that I'm trying to talk about. Okay, moving on to the third and almost last set of beautiful quotes. The roots of education are bitter, but the fruits are sweet. And this relates to something that I think is in the core of why is it that technology is not really working out right now. It has to do with the fact that, well, sometimes education is hard. Sometimes studying something, even alone or with a group, is just hard. And it's hard from many directions, and I find that for me, or for at least a good part of people I know, trying to study something that is complex falls in a very, very easy moment, and it's the moment that we didn't understand the definitions. It happens a lot in math, it happens a lot in algorithms, it happens everywhere, I hope. That shows that the material is deep, I think. So we come to class, we don't know the definitions. The teacher shows us the definitions in 5 minutes and then continues as if the definition sits in our brain as well as it sits in his. That is never the case. Okay? So I find that this is the part where we have to, this is where the roots are bitter. This is where we have to put in some effort, and how is it that we can use technology to help us? Well, this is kind of futuristic, but this is a project I'm running now. And it is that along with a person called Jakob Funk, who did a beautiful master thesis, I'm trying to use a Google Glass wearable, yes, to to do something of the following way. You read a paper, and there will be a definition. And then, well, here's the old way. You read a definition, you're not sure, you read on, you see this variable again, you don't remember what it was. You go back, you look at it, you come back, you're out of context. And that steals your time. Okay, this is one of those things that you learn doing a PhD, how to manage, and the funny thing is there isn't really like a big magic moment. It just happens by plowing through it. Okay, that you learn to be extremely careful about definitions. But I find that this is standing in the way between a lot of the students in any class of algorithms I taught and getting a good grade or understanding it or liking it. So being able to solve this technologically would be, I think, a huge step. So this is my future, I don't know, half year or so. So I guess I will end with another citation, quote, which I find most compelling for why is it that we're doing what we're doing, or why is it that at the end of the day, technology, I really honestly don't believe would do the entire 100%. So this is a citation of Barack Obama, and he said that a good teacher can increase the lifetime income of a classroom by over $250,000. He wasn't making up that number. This is a number from a recent study. A great teacher can offer an escape from poverty to the child who dreams beyond his circumstance. And I'm sure, living in India, you must have seen examples of that. And every person in this chamber, and this applies here as well, can point to a teacher who changed the trajectory of their lives. So teachers are definitely here to stay. It's got to be able to support it better with technology. Thank you.
So we have 1 or 2 minutes for any intervention.
So Ramsey numbers are quite complicated objects. So you showed us the case R33, and you still can show something on the board, but other than yeah, but I think for young kids, I mean, they grow so fast, so you can give this general lower bound may be possible, but to play around with that, I think if you go to bigger examples, then it will be intractable.
I'll tell you one thing, and this is maybe my own private example. I mean, without having really massive questions, I mean, you're not going anywhere, even as a 12-year-old kid. So if I give you Ramsey number and you see that this is an open, massive problem, if you remember the citation by Elder, she said that if we should find the average number for 5, then was it 5? Then okay, you can do it with all the mathematicians in the world. 6, if aliens are trying to invade you, well, you should develop war tools. Fine. But then, if a kid already made it to the point where he started thinking about it, I think that's a huge accomplishment for the teacher. Even if you admit to failing in this mega giant problem.
Yeah, that's a problem, that kid will fail.
Yeah, he would fail 1,000 times. Yeah. But that's
it's a really good motivation.
No, I think it's an amazing motivation because I mean, I agree with you that kids need a triumph. They need moments of triumph. Yeah. But they also need to know sort of scale. To know what is colossal, what is big, what is not so big. Yeah. So you show them giants. You have giants in your pocket. And I think that's something we can do which is incredible.
Yeah, I think we should take it a bit later because we are to the time. Maybe we should thank the speaker, and then after this session we have another 30 minutes for discussion, so perhaps we can take up some points.